Hello everyone, I hope you can hear me well. Today, not Sunday but Saturday. Tomorrow I'll be busy and yeah, we are here on the Microsoft terrace. This is no background, this is real shit going on here. Yeah, so today we're gonna do our regular stream, so we're doing LeetCode 75 questions. Yeah, today is my favorite topic, dynamic programming. With one additional thing, so I see already in the chat there is one thing, yeah, already one problem has to be solved. I think we will keep it to the end. Because today, as I promised last stream, and for those who've been to last stream, yeah, we're gonna solve a real Amazon question that I was asked in 2021. I think so 4 years ago. I got real interview at Amazon, and yeah, I was asked exactly this question. I completely failed. It was very bad. It was very bad. I mean, it was very bad. For this question, I got last 20 minutes, and I didn't even approach the right solution. So I revived and reviewed all my questions before, and today we're gonna solve it. Today we're gonna solve it. It's not that, oh sorry, no solutions. It's not that hard, especially it will be cool to solve it in the scope of the dynamic programming questions, because this is dynamic programming problem, by the way. So yeah, today this is gonna be the plan for the system design. I'm not quite sure how we're gonna proceed. Because yeah, last time we were designing the messenger, and maybe I would want to have a bit different approach. Maybe we're gonna do some POC of system design stuff that we're designing. I don't know, system design, if we type this thing, what do we have actually? So last time we were designing a messenger, and next thing is Quora Reddit Hacker News, a social network plus message board service. I'm thinking about different approach, because the thing is that usually system design might be quite different depending on the problem, but quite a lot of times what actually happens is that you have some patterns, some common patterns in system design. For example, let's say you're designing ticket server, ticket master, or something for booking of the events, something like that. And oh no, lofi hip hop. Let me change this into the lofi. Yeah. Let me know if the sound is bad. So what I noticed that there are quite some patterns that might be useful across the different system design solutions. For example, let's say you're designing some booking system. So booking.com, for example, will have this thing. Ticketmaster will have this thing. So let's say there is pattern called distributed logs. So you kinda might use it in different system designs to solve different kinds of problems. Usually it's consistency problems. So the pattern, for example, that we might design and even implement some little POC might be the distributed log, for example. Or as we did before, scalable monotonically increasing unique numbers generator, or something like that. Maybe we can go this way. It might be. I don't know yet, like what should be our approach. But yeah, for system design, let's leave it for as last part of today's stream. Right now it's LeetCode, it's dynamic programming. And hey Andrika, what a sunshine, how are you doing? Yeah, great today we're streaming. I'm doing good. Yeah, let's check also the problem that no condom Chris sent us. Excel sheet column title. Okay. well, for easy problem, that's kinda pretty low acceptance rate. Let's leave it until the end. I never seen this problem, to be honest, I guess, or did I? Submissions? No, nothing. So I didn't solve it before. That's all right. And let's start with the Fibonacci. So our dynamic programming. Yeah, so first of all, let me paste it to my editor. Vim motions are crucial. So the problem is pretty simple. Most probably all of you know the Fibonacci number when like some Fibonacci number n is defined as n minus 1 plus n minus 2. And this problem is pretty much exactly the same, but we also have plus n minus 3. So instead of 2 function calls, we're gonna spawn 3 function calls. And let's try to approach it as a regular dynamic programming problem. So it has few steps how you gonna come up with the brute force solution. Then you come up with bottom up plus top down plus memoization. Then you follow up it with the bottom up, and then you can optimize bottom up approach to the constant space. So first of all, let's the first thing you should do in any dynamic programming problem is to detect the subproblems that are going to be repeated. If you cannot detect this, maybe it's not even dynamic programming problem and you shouldn't even try to solve it, right? So in this case, for Fibonacci number, it's kinda should be easy, because let's say we're starting with 10, right? For your work life, for you, what is better, Windows, Linux, Mac OS, and why, or what's the difference in programming? So pretty much all my life I was using Windows for sure. I never had money for Mac, but lately for last 1.5 years I'm using MacBook. I got it as a present after helping my friend with his startup. So MacBook has some drawbacks for me. I am not quite sure, but it still has some advantages. I actually preparing the article about Windows versus MacBook for development and for usability in general. Actually, I would want to switch to Linux as a true software engineer. You should know Vim and you should know Linux for sure. So yeah, I actually at some point I will switch to Linux, I guess. Yeah, Windows is bad in terms of Unix system because it's not Unix based, right? So yeah, there is kind of solution or hack with WSL, and yeah, you have this Ubuntu, blah blah blah. You have it. You can do your grep and ls and everything here, right? It's not a problem. Also PowerShell has it. You can have Docker here, but yeah, in general, I'm not sure. I'm mostly used to Windows, to be honest, and also sometimes I'm playing games, so Mac will not be the great choice here. But from development perspective, actually, I don't have preference that much between macOS and Windows. Both of them are kinda enough. The thing is that when I'm doing some .NET, better usually to do it with Windows still. And if I do, I don't know, some React Native, it's better to do with macOS, right? Because I can run the native code for macOS basically. So yeah, I don't have much preference. I just got used to Windows, want to switch to Linux, but don't mind macOS. This is kinda would be the answer. So first thing for any dynamic programming problem is to detect the subproblems. So in this case, as we defined, our formula is so function for some Fibonacci number gonna be function n minus 1 plus function n minus 2 plus function n minus 3, and you're gonna kinda after some time you're gonna have it in your mind straight away, these pictures and abstractions. But for the first problems you might even draw it. So draw a call stack function, or sorry, the call stack of the calls, how it's gonna look like. So for any specific function for num n, you're gonna basically trigger 3 sub-functions. So your call stack gonna be this. Then for this one, we're gonna trigger 3 more. So it's gonna be 8, 7, 6. So I think you already at this stage, you see the repetitions. So we're gonna compute the same thing for number 8 2 times, for number 7 2 times, and yeah, and if you will proceed doing that, you will observe that there are a lot of computations, and if you are doing all of them, mostly, yeah, the problem is that each function call gonna spawn 3 more function calls. So it means at this level you're gonna have 3 to the power of 1. On the level below you're gonna have 3 to the power of 2, and so on. So let's say you have I don't know, number 10. It means you're gonna have 3 to the power of 10 number of calls, which is already kind of quite huge, and it's only for 10, right? And if we have input to, I don't know, let's say 50, you see it's a very huge number. It's because it's exponential runtime. So generally you don't want to do this, especially, yeah, constraint is 37. So 3 to the 37, and you see it's pretty big number. I don't even know how many bytes here, but it seems like 64 long number. So anyway, what you want to do, okay, you detected the repetitions, you detected the sub problems. That's already good. Now you want to code the brute force approach, so basically simulate this call stack. And to simulate this call stack, it's not that hard. I will start with separate function just because I know we're gonna evolve it and we're gonna need the separate function later. So let's name this function DP, dynamic programming. It's not great name for actual software you're gonna write for your company, but for the LeetCode it's exactly the, or maybe, yeah, let's name it compute. I don't like bad names. So we define in this function, we have some number for which we want to compute this, and if we go back to the description, we have some base cases. So in case number equals 0, we return 0. If number equals 1 or num equals 2, we're gonna return 1 as well. And now what we're gonna return is, let's even decouple it to variable, result or response, whatever. So we're gonna call compute number minus 1 plus compute number minus 2 plus compute number minus 3. And then we return this guy. And in the end, what we just call, we want to return compute for the number n. And that's basically it. It should actually work, but it will have exponential complexity, because every single compute call gonna spawn 3 recursive calls. So the time complexity for this guy gonna be the following. Or 3 to the power of n, where is n is our number, right? And this is very bad time complexity. It is exponential. Complexities, if you go here to images, to big O notation, you can see here, I don't know how well you can see, but yeah, this is O(n), just straight line, and when we have exponential, so our input is in the power part of the number, it's like very huge, very huge. We usually don't want this. So now how we can actually optimize it? And usually this is where dynamic programming starts. So first of all, be sure that your function is returning something, and your function represents some meaningful structured and decoupled subproblems. So in this case, my compute function means that this function is gonna return the Fibonacci number for number num. And this is well defined, and it's gonna return something. If you have your function that is not returning something, but instead keeps something on input, and in this case writes this input to some global variable, I don't know, append whatever response, and your response is carried as an input, it's not gonna work. It's not gonna work because you're gonna see it when we're gonna optimize it. So how exactly we're gonna optimize it? You can see that we have repetitions in the input parameters. I see the questions in the chat. I will get back as soon as possible, as soon as we finish with this problem. So for these repetitions, what we can apply basically, usually in software engineering, when you see repetitive calls to something, we're gonna cache it. So for the number 8, once we compute all this tree structure for number 8, once we've done this computation, we don't want to do it again because we already done it, right? And we write, once we computed it, the result of this number to some cache. And at this point, when we're gonna proceed further with our function calls up to the stack, we're gonna just use the same computation. And this way, this 8, for example, is not gonna spawn any recursive sub-problems. And how is it performed usually? Actually, it's pretty easy. So you just define some cache. It can be some dictionary. And just after your base cases, you're gonna check if your sub-problem in this cache, then you're gonna return cache result for this sub-problem. Otherwise, you're gonna compute it, right? And after computation, what you're gonna do, you just put in, you just put in the result for this sub-problem into the cache. So next time it's gonna be reused. Boom. And now the tricky part here is how to analyze the complexity, because yeah, I would agree that analyzing of complexity here is quite hard thing, because in this case better to think it that way. So let me draw exactly same thing again. So we have this sub-problem, this sub-problem, this sub-problem. We for sure know, okay, for now we don't know, but we will know later on. So this guy gonna be, yeah, by the way, we are doing kinda, on our call stack, we are doing kinda pre-order traversal of our tree. So we're gonna go left sub-tree first and gonna investigate it from the left bottom to the right. Basically, this is our call stack. This guy gonna spawn 8, 7, 6, and let me do just one more layer. This guy gonna spawn 7, 6, and 5. From now on, it's a bit hard to tell what will be the complexity for dynamic programming, right? When we apply the caching. So what will happen that at some point we're gonna reach the base case. So at some point the base case will not be actually cached because we return the base case upper. So it's not gonna reach this point. So we're gonna start caching from number 3. So at some point there's gonna be number 3, which we're gonna put to the cache. Say this is number 3. It's gonna call these two guys that are not going to be cached. And for number 3, it's gonna be 1, 1. It's gonna be 2, I guess, right? So 1, 1. Yeah, it's gonna be 2. And later on, 3 is gonna be used as well for number 4. Sorry, different arrow direction. So number 4 is going to be using this guy, so layer above. And number 4 is going to be used for number 5. 3, 2. So the thing is that since we go all the way down, as it's kind of pre-order traversal of our call stack, once we computed number 3, this tree is going to be used later up to the call stack, and it will be returned from the cache. Same thing going to be applied for the 4 in number 6. So this 4 is going to be computed already, so it's going to be in the cache. So the thing is that basically we're going to compute all the way down our left branch, and for all subsequent calls that are going to happen next, we're going to use kind of pre-computed cached values. And this is cool stuff, but we're still gonna go to these all branches, and we're still gonna perform kind of their computation, but not fully, because we're gonna get back to the cache. Overall, the complexity here is going to be changed to O number to the power of 2. So from the exponential, it's gonna be squared. Still not linear, because we're still gonna do a bunch of calls. Or wait, no, it's gonna be changed actually to linear, I guess. We're gonna actually check it later, but yeah, the thing is how you should think about that is that once you computed or you processed the result for some number, you're not gonna process it again, so you're just gonna return it from the cache. And how many such processing is gonna happen? It's gonna happen the n times, so that's why complexity is changed to O(n). But better to check the complexity of your dynamic programming approach is to change it to bottom-up approach, because this is top-down. It still uses recursive calls, but we're putting cache on top. And usually your interviewer is going to ask you, okay, let's follow up and let's change it from recursive, because recursive approach is bad. It costs you more because you're gonna call function instead of just one iteration. It has some flaws like stack overflow and stuff like that. So usually you're gonna have additional question like let's change it to iterative. And this is what you should be actually ready for. This solution I guess still might not even pass. No, it did pass. So because it's kind of O(n). But how we can improve it further? So before we go into, so this is, let me put it, this is top-down approach, and we're gonna put it to bottom-up. Bottom-up approach is better because it's iterative, so it costs you less, has better properties in terms of memory usage. It's gonna go to heap instead of stack. I mean, it's still gonna use stack, but it's not gonna spawn a lot of recursive calls, so you're not gonna get stack overflow. And it's faster and it's easier to analyze the time complexity with bottom-up. So I should now check the chat. So what do you think Uber is using WebSockets or not in their mobile apps network stack? This is actually a very cool approach. Very cool question. We're gonna do some Uber, Lyft, Bolt system design, but let me think a bit about it. So it's our chat, whatever. So let's say there are a bunch of clients, right? And the thing is that with Uber and Lyft, it's kind of, they should be consistent, right? So their requirement is to, so maybe they're gonna use some kind of distributed locking as well, because you don't want two riders to approve or to confirm the same ride. So yeah, you don't want two riders to be in the same ride. So let's say there is a server and somehow it should send notification about some ride that needs driver, right? Well, but you want it as fast as possible, right? I actually think they might use some kind of sockets, because this notification is kind of critical, right? You want to have your ride as fast as possible, and you don't want to do polling every second, I guess. So most probably they do use it. This would be my guess. I'm not sure. Maybe it's not quite needed, but for this notification, it might be that they are using it. Maybe they're using some other push mechanism, so there is something called notification service, and it just pushes the notification somehow using some mobile technology for push notifications, right? But also it might be socket connection. I guess it might be. So yeah, once we're gonna do system design for Uber, we're gonna explore all the options, but it can be done even without it, right? It can be polling, as I told you, so clients might be just polling every second. I think it might not be that critical, but still it may be much cheaper than maintain the WebSockets, because it's state, it's hard to scale, blah, blah, blah. So polling might be good. 1 second. I actually would do it probably with Poland because it's easier, cheaper, and much straightforward solution, which will actually save you a lot of money. This is my guess. Or maybe push notification if there are all mobile clients, because I have never seen any driver that is using some client that is not mobile, right? Bro, my Jeff broke up from me. I feel sad and demotivated. How do I green LeetCode and study? Lost all motivation. Oh, this is very sad, man. Yeah, sorry for that. This is sad. I don't know actually if your Jeff is breaking up with you. So for sure your kind of self-confidence decreases a lot. But for me, usually how it works for me, I don't know about you and how do you approach this, but this drives me in a different way, that it gives me much more motivation to do stuff, kind of to prove to the GF that broke up with you that actually it was a mistake. It's a bit stupid thing, right? But it raises so much competitiveness inside me that kind of to prove stuff that I would actually green so try to think it in a way, but don't do anything to her, right? Don't post messages, don't do anything. Just make this inside yourself. So build a mindset where like, it's a bit not healthy stuff. Most probably you're gonna go to some psychotherapy, right? This would be the better choice because I'm not psychotherapist, right? I don't know. But yeah, for me, how it would work, that I would try to prove that it was mistake, that she broke up with you. So you're gonna become like 3 times better boyfriend in all senses. So you're gonna have more money, you're gonna build some, I don't know, body, you're gonna go to some martial art, I don't know, boxing, whatever. You're gonna do this stuff for quite a consistent time to kind of prove that you're actually good and it was kind of mistake. And after that, I think you're gonna be all right. This is how I would approach this thing, I guess. But also being sad is kind of okay. So I don't know, for me what works, I would maybe, how is this thing called? Diffuse in some content for a couple of days and then just work, improve and kind of prove to myself that I'm not a piece of shit. But yeah, I feel sorry for you, that's okay. Hope my stream might help you. Hey, first time here, could you solve some digit DP problems? Yeah, send it out to me, I will try. Where are you sitting, bro? I'm sitting on the Microsoft Office terrace. This is not background. Yeah, because some of the people are asking, is this background? No, it's not. It's all real. So yeah, on the Microsoft Office terrace in Prague, I'm sitting. Let me fix this. Yeah, this way. Okay, gRPC. Well, gRPC is still kind of analogy to HTTP, which is kind of a bit more performant, right? But it's still not near real-time communication. So thanks for your advice. Man, you're welcome, but I'm not sure my advices are that kind of good because yeah, I'm not psychotherapy. I've been in your situation before, of course. I've been on your seat. Yeah, and I reacted just differently. It moved me to different mindset to actually do more and achieve more. So yeah, let's get back to our questions. So office hours, exactly, office hour. Oh, sorry, office tour. You can find office tour actually on my channel, I guess. Did I do it? I guess I did. So just go there or on my TikTok. So yeah, Microsoft Office in Prague. Yeah, just check it. You're gonna find a lot about Microsoft. Also terrace review is there. Also you can go to my TikTok. I'm doing stuff there as well. Sorry, just quick reminder, don't forget to subscribe on Telegram because all updates, stream schedule, stuff like that is usually done there. So, and also internal stuff from Microsoft, Corpo, interviews, all these things. So, now that we have this improvement, so we made our runtime much better by caching, let's convert it to bottom-up. And to convert it to bottom-up, the usual approach, since in the top-down approach we're going from top, from the 10 in this case, to the down, to our base cases. For the bottom-up, how we're gonna proceed is that we're starting with our base cases. So in this case, base cases, and the number after base case is gonna be 3. We're starting from our 3 and building this cache kinda from the bottom to the up. So we're gonna build, calculate, and process or compute the value for number 3 for subproblem 3, then for subproblem 4, because we already have response for subproblem 3, then for subproblem 5, subproblem 6, 7, 8, 9, 10. In the end, we're gonna compute the answer for subproblem 10 in constant time, because we already have computed subproblem 9, 8, and 7 before. And then we're just gonna return the result for subproblem 10. And this is as simple as that, but there are a lot of struggles with that, because it's kinda hard to convert recursive dynamic programming top-down approach to bottom-up, because it's kinda hard to think about it in terms of code. In terms of call stack pictures and abstractions, it seems pretty easy, right? So instead of going here recursively, we are starting from the bottom and building it bottom-up, right? But how exactly this is expressed in the code, and usually I'm doing this procedure, so you leave your top-down approach on your editor, whatever, and you just start doing it with the for loops. So of course you're gonna do some iteration, and you're gonna basically kinda copy-paste this function with one change, that instead of recursive calls, you're gonna use cached values here. So let me actually rename this guy to DP. Or even, yeah, let's define it as a DP, because usually this is how people call the cache. So now, since we're gonna do iteratively, and we know that it's kind of contiguous result, instead of cache, which is kind of random accessed data structure in this case, we're gonna build an array. An array is gonna be length of n, or n plus 1, because in the end what we want to return this. And now, since we are starting from bottom, the first item that we actually gonna compute value for, except the base cases, is gonna be 3. So we're gonna start with 3 for number in range 3 n plus 1. And now, we are doing exactly the same things, but first we're gonna put the base cases into our DP array. So for number 0 is 0, it's anyway 0, but I'm just explicitly putting here 0, so that it's kinda easier to understand. For base case 1 and base case 2, we are putting number 1. So dp1 equals 1, dp2 equals 1. So our base cases are defined already. Now we're starting with 3, and we're computing the value for num as this one. You can just copy this guy completely. Oh, sorry. And put it here. So dp or result equals dp, and dp num equals result. And in the end, we just return dp num. So you see, it is function call, but now we are changing it not to function call, but to our array access. Because it's, in a nutshell, it's exactly the same. It's the pre-computed value for this specific subproblem. And that will be it, but we're gonna have some of the edge cases, because our input where it's constraints can be 0. So our input can be the edge case itself, or sorry, the base case itself. So in case we're gonna have 0, we're gonna create array of length 1, and these two gonna fail because it will be indexed out of range. So for this case, we might just put this thing, and that would be it. This is for edge cases, in a sense. Now let's just copy it, check whether it works or not. Oh yeah, it's M, sorry, this is M. Yeah. Great, and it's gonna work as well. Yes, done actually, nicely done. And then the third part is, actually it's not quite optimized yet, because we have time complexity, it's much easier now to calculate the time complexity, because since we reversed top down to bottom up, we clearly see that there is only one single iteration which gonna iterate over n, which is our input. So we clearly and easily can state that our time complexity is linear, and space complexity still linear as well, because we're going to create the additional space of length n. The last optimization for dynamic programming problem is going to be this one. We're going to change space complexity to constant complexity. How are we going to do this? So you kind of might observe that in our call stack, once we computing value, let's say for number 8, we actually are not interested for the pre-computed values of number 3, 4, because we're gonna have just 7, 6, and 5. So every single time we're computing bottom up, we need only 3 previous values. So instead of array, actually what we can do, we can remove array completely, and we can kind of state that first, or just not removing it, just let's change it. So this is gonna be first, this is gonna be second, this is gonna be third. And now, instead of accessing the previously computed values from the array, we're gonna just compute it in the following way. So next, where is the indentation? Oh my god, what happened? Okay. So next third, which is our biggest value, is gonna be third plus second plus first, emulating basically this line, right? Now we're just shifting it upper, so now our first becomes second, our second becomes third, our third becomes next third. And in the end, we just return the last computed value, which is going to be third. Yeah, DP we don't need to compute now. Good. And now our memory beats only half of the submissions. So let's check this thing and let's submit. Now it should beat more. Still somehow it's 48. I have no idea why, because but in the nutshell, you can see you can look at the solution and check that there is no extra allocation of memory. We're just playing with 3 static variables, which makes this solution have constant space. And at this stage, this is considered kind of sole dynamic programming solution. So the algo for solving DP, oh shit, I don't want, no, I don't need, no, please stop. So algo, come up with the brute force solution. Function should return value for specific sub-problem. So this is the first step. Second step, build cache on top down, convert to bottom up. I explain you how to do it. You just basically get the body of top-down approach, think it in a way that you're gonna build stack from the bottom, and instead of recursive function calls, you're gonna call your pre-computed results from array with exactly the same parameter. And next step, improve space complexity to constant. Sometimes on your interview you will not have time to, to demonstrate that you do every single step for this. So usually after, I don't know, dozens, I don't know, hundreds of DP questions, what you're gonna do is you kind of build it straight away, and you don't even start with brute force. You kind of already know what would be your brute force function. You already know what it's gonna represent, which subproblem, what it's gonna return. You might start with top-down straight away, and then you can convert to bottom-up. Or you can sometimes start with bottom-up approach straight away, and then maybe as a follow-up you can improve space complexity, depending on how easy the problem seems to you. So the chat, thanks for your advices. Sorry, this was already Office Store. Yeah, check the YouTube. What kind of technologies should I use in projects so that my resume gets shortlisted in big companies? No, it's not about technologies. Sometimes it's about technologies when we talk about smaller companies, but in general, it's not about technology. So in order to be visible to companies and to not be ghosted by the recruiters, you need, first of all, you need references. Referrals. You need referrals, so find somebody who's gonna refer you. Second thing, you're gonna build a good resume, but in terms of your experience. So learn how to build resume, how to build quantified impact for every your project, so you can demonstrate how did you influence the business and the real things on your project. Like, I don't know, you saved this amount of money, you improved this percentage of latency, you improve this percentage of reliability, blah, blah, blah. Next thing, you're gonna have real experience, so commercial experience. If you don't have it, go to uni, go internship, or rely on your CV and start with smaller companies, and then kind of proceed. Yeah, and that's basically it. So you're gonna have real commercial experience, good resume with valid quantitative impact, and referral, and this is gonna be enough. In case of internship, same thing, but you're gonna have university, and then just apply for internship positions where you gotta get the commercial experience and then build up for the software engineering. Also, one of the things, if you don't have commercial experience, you might try to contribute to open source, but it's in general pretty hard and not paid, so up to you. Good, we solved this question, and now actually I think it might be time for the Amazon question. So yeah, for these guys who are new in the stream right now, 4 years ago I got real interview question from Amazon, and I got asked this question. I totally failed, like completely failure. And yeah, today we're gonna solve it. This is actually not that much easy question, because actually the LeetCode analogy, so the problem that actually pretty similar, is hard. But I would actually rate this problem as a middle, to be honest. I wouldn't say this is hard. So let's start solving it. Yeah, this is our input output. Let me put it here. So we have the following thing. Shit. Yes. Why it's Markdown? It should be Python. Sorry, guys. So let's define it as a, I don't know, main, whatever. We have words. So, given large list of words, some of these are compounds where all parts are also in the list. Write a method that will find all combinations where one word is a composite of 2 or more words from the same list and return them. So basically, there is word rockstar, and there is subwords rock and star. If you combine rock and star, you're gonna have word rockstar. So you're gonna include it in your output. Same thing happens with word rocks and tar, because it adds up to rockstar, so we're gonna include it. Then you have superhighway, which is going to be included, or sorry, decoupled to super and highway, or super and high and way. This is our question, and we're gonna kind of solve it. We actually, on the real interview, I had only 20 minutes for that. So basically, in the scope of dynamic programming, try to analyze, do we have a sub-problems here or not, and how we might decouple these sub-problems. So in our case, let's start with the basic example, rockstar, or even superhighway. I think superhighway is much more explorable. So I actually will go to Excalibur because it will be a bit easier for me. So we're starting with this one. We're starting with superhighway. Okay, so how are we gonna know that superhighway might be created by, sorry, where is the description? That superhighway can be created by words in the list that we are given. And what is how we can basically check it at all. So the brute force approach would be to actually try every single suffix and check whether we have already this suffix as a separate word. So let's put our input here as this. We have superhighway, we have super, we have high, we have way, and we have highway, I guess, right? We have highway, yes. Let's do highway. This is our input. Oh my god, Excalibur, please. Okay, this is our input. And how are we gonna check it? So we're checking the prefix S. It is not in our list. Prefix su, not in our list. Sup, not in our list. Super, not in our list. Super, we found the word in our input. So in this case, since we might have, for example, this split as well, right? We might have word super high and then way. We don't want, we cannot kind of greedily split here because this might not be the only possible split for this word. So at this point, we're gonna kind of branch our behavior into two. So one branch of our behavior or of our algorithm is going to consider only this word as a remaining, as we're deciding to do a split here. Other branch will keep still trying all possible prefixes. Maybe we're gonna have a split later. So we kind of continue doing prefix check. Is a super H in list? No. Is super HI? No. Super H, super HIG, and so on. Maybe at some point we're gonna actually split it, right? So it might be the case that here we have super high as a word, and in this case we again gonna have branching. So one branch of decision tree we're gonna split here, another branch gonna continue checking it, and in the end we're gonna find this word in our word dictionary. So yeah, this already seems like a bit of the, I think you kind of should already see that there is definitely a sub-problem structure, because this guy gonna split on the super, super as a split word and highway as a remaining word to be kind of computed. Another branch here would be super high and way to be computed, and another branch here is going to be super highway, and we're done. Now the same happens with the highway. because we again trying to check prefix. We're gonna reach high as a split, and we can decide split it or not split it. And here we're gonna have also two decisions kinda. First one is oh my god. Okay, I'm gonna use this one. First one, we might want to split it. So in this case, we're gonna have super high and way to be explored. And in that case, in the next case, we kinda gonna proceed, and in the second branching, we're gonna have super highway, highway, and empty string left to be explored. So in this case, I guess you kinda already might see the repetition, because we have way to be computed here and way to be computed here. If we explore it later, you can see that highway actually also going to be split, because our highway can be represented as high and way as a separate word. So in our example, you can see here that super highway is going to split it as a super highway and super high and way. Actually, highway also going to be split as this one. So we're going to have high and way. I propose actually to return instead of this. So we build output in a different way, so it's more understandable. We're going to build it as a map. So we're going to have the target word and compound array that is going to be compounded. So for example, for rock star, we're going to have rock star, an array of possible groupings that we can build to add up to this word, because it will be kind of more understandable. So now, after this kind of going through the problem, you definitely can see that there is branching, so it's exponential, because if you at some point of your function you're gonna branch and call recursively two sub functions on the different input, most probably it's kind of branching, so it's going to be exponential. It might be the dynamic programming. So what I propose to do, we're going to define a function, because first step for any dynamic programming algorithm is to define a function which as input gonna receive some sub-problem input, and it's gonna return the solution for this sub-problem input. So what I propose to do is we defining function, I don't know, compute whatever, compute, and it's gonna accept the word, and it's gonna return the group with which this word can be generated, kind of. And if we have, let's start straight away with base case. If our word length is going to be 0, we just return empty one. This is pretty simple because we cannot group anything here. Also, to quick check for the prefix, so let's say how can I know that super is presented in our input list. We're gonna put all the words into hash set, because then I can check super presented in this list in a constant time. Otherwise, every single check is going to take you over, which is not good. So our hash set is going to be here. Do we need to count them? I don't think we need, so maybe it's going to be just set. Hash set at word. Good. And now for our word, we are checking every possible prefix. So we are starting with index in range. Bro, where to learn DSA to build strong foundation? University, if you're smart enough and rich enough. Otherwise, if you need it only for interview, I would propose just solve LeetCode questions and go through the solutions, learn it while you're solving it. So we have our iteration, and we're going to check every single possible prefix. So what do I want to have here is to calculate the prefix somehow and check whether it is presented in the hash set. If it does, we're going to spawn additional branching like as a decision to split at this prefix. So this is going to be our result. And how we want to split? We definitely don't want to split on empty prefix, so we're gonna start with 1 and end with length of word. Now our word is going to have from 0 to I. This is going to be our split. So in the beginning, from 0 to 1, as 1 is exclusive boundary, it's gonna start with just single character to check. And then, yeah, we're gonna check if this prefix is in map, if pref in hash set. In this case, we kinda yeah, sub result, or yeah, in this case we want to do this result append. But what if it's not? Yeah. Yeah, so yeah, in this case prefix is in the map. What we want to do is sub result to be compute word starting from index I to the length of the word. Right, should be it. And now if length sub response is more than 0, so it can be built, then we are doing this one, sub result append prefix, or I don't know, we can do, yeah, let's leave it, oh, shit, sub result append prefix. And now result append, or we can do actually here prefix plus sub result as this one. Yeah, it will do a concatenation of the arrays. Yeah, and if sub result is empty, so it means we actually cannot form any we cannot split and form a compound word. In the end, after this for loop, we're gonna return a result. And yes, this is going to be, and now, yeah, for now let's leave it as it is. We're gonna go through it a bit later. Now we're gonna have for word in words. There is no caching yet. We're going to check group equal to compute for specific word. If length group more than 0, let's define our result kind of, it's going to be map, and or it can be actually array and tuple. Yeah, let's do array and tuple. It will be a bit easier. So result append, we're adding our tuple, which is gonna consist of word and group. In the end, we return result. So let's actually run through it and try to check what will happen for the super highway. So yeah, at some point we're gonna check and split on super and highway. Yeah. Yes, exactly. Okay. And in this case, the first call stack is going to be super high and way as a part that left, and also super high way, an empty string that will be left, right? So nice. I guess, yeah, should actually work. But one more thing, what we want to do here hash set remove word. I'll explain you later why did we do this. This is very crucial part, and we're gonna run once without these things, and you're gonna see why we are doing this. So yeah, we're checking every possible prefix. If it's not in hash set, we kinda don't care, right? If it is in hash set, we kinda compute the sub problem with what is left, and then if we can split further word, we're adding it here. Yeah, should be it. Our boundary here. Yeah, actually here also what should we do? I don't think we can have length word equals to 0, because let me explain you why. In case we have ABC, we are starting our range. Oh my god. We're starting our range from 1 to length, in this case going to be 3, so 2 inclusively, and suffix that is going to happen here. So let's say we have on our upper range, it's going to be from 2 to 3, which will give us a character C, and character C gonna start with 1 to upper bound 0 actually, and it will spawn us nothing. So in this case, I guess what we should do, if word in hash set, what we should do, we should append it here. Yes. Now let's write test here, and we're gonna run it. So main print main, and our words that we want to include as per problem is this, guys. Yeah. Oh my god, I now should put. Okay, I think this is when I'm gonna use. Oh shit. When I'm gonna use my mouse to actually put it. I'm sorry for that. Okay, and now let's check how it's gonna run. So to run it, let's just, I don't know, let's, I don't know, save it somewhere. My god, projects, TMP, test by. File, open folder, this folder, yes, please, faster. Where is terminal? Where is open terminal? Wait. Yes. Okay, so Python main, sorry, test py. Okay, so we have first problem, of course, that makes sense. Preface address. I can concatenate what? Yeah, sorry, makes sense, because this is prefix is string, but sub response is array. It cannot concatenate. Nice, we have some output, which is great. It seems to be working, right? So for rockstar we have rock and star, rocks and tar. Also for rockstar we have rock stars and yeah, you see there is Rockstar without S, and this is the S in the end. That's why. For highway we have highway. For super highway we have super highway. Okay. Yeah, which is kind of makes sense, right? Because we can have super highway or super high and way. Now the thing is that this is exponential here, so the time complexity, usually when you see this exponential you can straight away say something like 2 to the power of n, but actually it's even worse here, because we might spawn the m number of subcalls here, so m to the power of n, because there is m lengths of the max length of the word, we might spawn m to the power of n calls. What does it mean if we have super highway? Let's say, let me draw it here. So we have, okay, let's say we have super. So we have our m is equals to 5 as the length of the word, and yeah, n is equal to, in this case, no, it's actually more tricky. So for super we might consider s, we might consider su, we might consider sup, all prefixes basically. And super, yeah, this one, no, it will not be a spawn call, so let's remove it. Yeah, so this is kinda m, where is m is length of the word. This guy gonna again spawn u, sorry, up, so in a happy path, when all of them are present in our word list, every single function call gonna spawn m recursive function calls. This is what I would say here, right? So how can we improve it? Because in this case you can clearly see that for highway we are doing this computation twice, because we need we found already that highway can be compound of high and way. But in super highway, when we reached and split on the super, we have highway, which we already kind of computed. It is highway and split. So how can we kind of compute it further and optimize? In this case, pretty simple, we can put cache. So yeah, and our cache will represent what? It's gonna represent exactly the group for specific word. And in this case, what is going to happen is, yeah, at this point, once we reached our, after the base case, same algorithm exactly. If word in cache, we return cache word. And in the end, if no, just for cache, word equals result. Yes. Let's actually try this. Rockstar, okay, star. Yeah, now there is one problem. Yeah, and the problem is actually, Oh, let me actually check it. So the problem here is that you see that we got a new response, that tar is equal to tar and star equal to star, and we actually don't want these words because they are not compound to rock star, right? We might want them, right? But it seems like this guy didn't have any impact here, that we removed it, because now since we push this cache, at some point we're gonna compute cache for prefix star, and we're gonna put it, and it can be called again, and we're just gonna return it here. So what I would put here maybe is that if I put this one, I don't think it will improve that much. No, actually it improved it, right? But now we don't have rocks stars. But I think, okay, can we find rock stars? I'm just validating the output, right? So we should have rock star, superhighway, and superhighway. Yeah, I would say this makes sense. Yeah, this makes sense. And with this one, with this improvement, what happened with the complexity is that now instead of m to the power of n, it became what? So we're gonna call this function only once for every possible word. But it's very hard actually to calculate, because if all the words, it depends on the input, right? If all the words are different, I mean unique, and they don't intersect anyhow. But yeah, we can, yeah. So in this case, highway, and at some point, yes, seems like it will help only if we have repetitions in our, only if we have repetitions across the words dictionary that we got as input. So yeah, it is improvement across the words basically, because for every separate word, we kinda not gonna have any problems, right, with the brute force. I mean, it will be brute force anyway, so we cannot save it that much, because only if we have some repetitive word, like for example, you have word, and word. Yeah, if you have this kind of word, right, then this thing. And once we compute this guy, yeah, it will help. It will not compute. Yeah, so it barely, it explicitly depends on the input. If input cannot have kind of repetitive thing, then our improvement is only for across the words DP computation. So it was a divide and conquer type problem rather than complex DS1. In Amazon, yes. In Amazon, yes. So yeah, this is the Amazon question. Kind of not that easy, I would agree, but still doable. Maybe I actually would say that let's do one more TP. Oh yeah, I actually promised the guy to solve this problem. I never saw it before, so let's check. Given integer column number, return its corresponding column title as it appears in Excel sheet. A, B, C, A, B. Is it how the Excel works? Okay, let's say, oh my god. Okay, this is, okay, anyway, I will not even open it. Excel columns, let's check this one. Is it going like that? So, no, not this one. So it goes Z26, AA27, $701 ZY. This one I don't understand. Okay. Just let us ChatGPT. How Excel columns work. After this A, B, A, Z, then BA, BB. Okay, and once we are over with this, like, I mean, in this question, right, what is the column number? Column number might be, so once, let's say, if we are in situation ZZ, right, we're gonna spawn, the next one is AAA. So we spawn new number every single time we finished the previous kind of number. So I would maybe represent it as an array, right? So first we might have number between 1 and 26, right? Yeah, and 26 is 7. So 28 if reminder is 2. Yeah, so 26 is going to be from A to Z. AZ. Then next one is also 126 AZ, and so on. And in case we have 28, let's say we divide it by 26, reminder is going to be 2. Yeah, this is actually a pretty interesting problem. So 26, 27, 28, and so on. And we have some very large number. Isn't it very similar to add up something? So we kind of need to have carry. Hey, I was wondering what since I should start learning to become AI engineer. Oh man, AI engineering is very hard nowadays. You should go to university and get a master's at least, but even better to have some PhD in AI, and then you can go. Like nowadays, AI companies require you to have a diploma and usually even PhD. So education. Only through the education, I guess. So let's back to our problem. We have, let's say, 26. So once okay, so Yeah, let me think about it. So when we have some huge number, right, for sure we should divide it somehow with 26, because 26 is the number of characters that can be in one column. So for the first column we have 26 options, right? For the second column we have 26 options, which in total should be 26. Yeah. So for 700, for this case, the example 3, 701, 701 divided by 26 rounds to 26. So isn't it just division problem? I mean, so first we kind of divided some number, we divided by 26 and floor it, right? We have some number 2, which is going to be 26, right? 701 divided 26. Yeah, it's going to be 26 to the lower bound, and since this number is more than or equal to 26, we're going to divide it again by 26, and we're going to have 1. So since 26 kind of got there, but I still don't understand why it's ZY. So number-wise, it is 26 and 25. What are your thoughts on blockchain? Is it something with huge scope? Nowadays, I don't think so. Nowadays, I think crypto got a bit less hype. Now AI is on the hype. But crypto makes you good money, right? So again. I mean, we can do it with brute force, but there should be some mass applied. So brute force solution would be just to iterate over the column number, right? But it's a bad solution. Let's maybe try first with the brute force, and then we can optimize it further. So for brute force, we are starting once we reach 26. We kinda should spawn a new column and increase previous one. Yeah, so kinda if we represent it by an array, right? So let's say we're starting with single number, we reach 26. Next number is gonna give us 1 and 1, right? Then 2, 3, 4. Once we reach 26, it's gonna spawn us 1 here, and this becomes 1 as well. No, this is, yes, this is not a thing. So once we finish with one number, it becomes 1 and spawns 1 again. Okay. Just a second. So in this case, when I reach this 26, we don't need, yeah, we just increase previous one, and this becomes 1. Once this becomes 26, we increase previous one, 3, and if here is 26, we increase here 1, and next one gonna be here. So yeah, and in this case we're gonna spawn 1 again. Yeah. So 26 here becomes 1, and here we're gonna and we want to have it like that, right? And now 26 here becomes 2 here. Okay, so I would say that a brute force solution would be the following, that we iterating we have, I would say maybe it's better to have even a queue. Yeah, so it grows, because let's say we have this one, right? And at some point we're gonna have 26 everywhere, but it's gonna be very large number, right? And then when we increase again, it's gonna be 1, this is gonna be 1, and the last one gonna split on this. So kind of when we reach 26, we're gonna increase the previous one. So it's kind of carry, right? When here is 26, the increase gonna be again carried to the left. When here is 26, increase is gonna be carried left, and if there is no left to be carried, we just spawn additional one here. And then we can just convert these numbers back to the big characters, right? Somehow. Yeah, by using a Unicode table or something like that. So okay, let's just try brute force. I'm not quite sure it will pass. Linear solution here, I'm not sure it will pass, but let's at least try. At least we have some understanding. So we want to easily insert from the left and from the right, so probably we're gonna have some dequeue. This is a bad approach, but it will at least work. And we have some number, column number in range 1 to column number +1. And here we go. What are constraints? We're starting with 1 at least. If queue is empty, we just queue append none, continue. If it's not empty, we do our algorithm. So the last element yeah, but we don't have it. Yeah, we cannot reach it to the index, that's a problem. If we reverse it, will it work? Yeah, maybe we can reverse this guy a bit, and then we will be in a better situation. So let's say we reversed it, and we have this situation, right? And this is 26. We make it 1, this one make it 1, and this one make it 1, and append this one. Yeah, let's just reverse it, fuck it. So array is equal to this guy. If array makes, we just adding. And now we're gonna process index, right? Okay, array index +1, while array index more than 20. Yeah, more than 26. What we're gonna do is array index equals 1, array What the hell is indentation again? I see. Array. Yeah, I'm not sure about solution as well. This is the new solution that got sorry, not the new solution, new problem that got pasted in the chat, so I'm trying to solve it. I'm trying to first solve it with the brute force, which seems to be kind of similar to sum, custom summing, because we need to care about carry. Yeah, exactly. So then array append 1 break. Yeah, something like that. And then what we should do in the end is to convert our resulting array to result equals this guy. So how we can do it? While an array is more than 0, number array pop, and we want to convert number to this ABCD, and for that it's gonna be character, right? So how to get, yeah, so original Unicode for this number, since it represents the numeric value in the alphabet, right? It's gonna be yeah, it's tagged easy, but you see the acceptance rate. You should check acceptance rate. So code, it should be ordinal A plus number minus 1. This is our code, and then character is going to be res plus equal code. Let's just try this. See, it's very bad in terms of complexity, right? But let's just check it. 28. Let's see how it's gonna work with 28. We return only A, right? And here we return only A. Here we return only A. Okay, seems like, yes, well, because this guy gonna be here. Yes, it passed. So yeah, but most probably we're gonna have time limit exceeded. Yes, so for sure we're gonna have. Yeah, for this kind of problems, when brute force is giving you time limit exceeded, most usually it shouldn't be easy problem. But let's now think about improved solution. So every single time that we exceeded like the number of one column, so let's say we got 26, every single time it's next 26, we're gonna spawn one more character, right? So giving back this example with 700, let's come up with some formula. So 700 divided by 26 is going to be 26. So 700 divided by 26 is going to be 26. But 700 remainder of 26, what is going to be? 700 divided by 26 is going to be 25. This is probably most operations that we're gonna do here, and let's check it, right? Yeah, I guess what we can do is Yeah, so seems like we have some number and we have some function for this number. Oh, let me actually maybe code it right. So we have compute whatever number. It was supposed to be dynamic programming problem, but yeah, thanks for this guy who pasted a quite new problem here. We are now solving it. So number, how it should be, if number is less than or equal 26, return 26, right? Right. Otherwise, current value is going to be, current number is going to be number divided by 26. Yes. And we return current number plus compute number, something like that. And then we return compute column number. So for 700, because this is like, I kind of tried it inductively, right? And I see that this might actually work. So for 701, dividing by 26 will give you 26. And we'll spawn sub-problem for 25, and 25 is gonna lead you to 25. Or sorry. And then after, yeah, we're gonna just, this is gonna be our array, and then we can just or not pop. Okay, let me, since this one was reversed, we can just do this. So for e in range, reversed range play array, and this is gonna be array I. Something like that we can do, for example. I'm not quite sure how good this solution is. What do you mean? Or maybe actually here we can return straight away. Why do we need this, right? We have code and everything, so we can maybe return current code -1 exactly. Yes, so let's return characters straight away. This one, yeah, sounds like that. Let's try it. Oh shit, we don't actually need this guy. Float object cannot be interpreted as integer. Ah yes, because we need to do this. Ah. Yes. Let's try this. Bunch of mistakes. No premium, no premium. Good, we solved it. Now complexity should be much better, but still. Yeah, this is actually the problem. If we divide this one by 26, it's gonna be a lot, right? shouldn't we do that then in case a problem? Like this, right? Yeah, in this case it's gonna be just this one. Shit. Yeah, let's just try it. Yes. Ah, fuck, it's some Unicode problem. So in case of 52, what, like why? Why so? What is the problem? Like, why it doesn't work? Divided by 26, it's gonna be 2. This gonna have 0. Ah, fuck, yes. And if we have 0, be like +1, but I'm not sure it will work, to be honest. Yeah, it shouldn't. Like this. Okay, the problem here is that we have 0 reminder. In the case of 0, okay, so if number is equal 0, we should return what? Should return z. This is hack, I don't like it, but oh my god, what the hell? AZ, BZ. So we want this code to be one more. So 52 divided by 26 is 2. So we have like 2 plus 0. Do you have any hints? I don't know. No hints. This is not easy question, guys. I would say it's not easy. So for A, we should have AZ, right? But now it's correct. It should be some edge case that, okay, let's do this. First num divided by 26, second num mod 26. It should be some of the edge cases that if we have reminder equals 0, it seems like this guy then we should call with 1. So if second equals 0, then we should return compute. First gonna have first plus 1, right? Because if 52 divided by 26 is gonna be 2, or no, minus 1. Yeah, minus 1. I'm just trying to fix it for this test case because, yeah, and then we're gonna see the real answer. Shoot with, no, this one, this 26. Oh my god, this is bad. Let's just make it pass and that's it. Yeah, it passed. Nice. Well done. The complexity is log n, since every single time, yeah, 26 consider it as a constant. Consider all constants as 2. So if 26 will be not 26 but 2, every single time we are dividing number by 2. So in the end it will be kind of binary search complexity, which is logarithmic, but with the base not 2 but 26. Let's check the actual answer. So convert blah blah blah. So converting, okay. Yeah, this is actually something that we got, yes. Python. Yeah, the original brute force, but it's gonna be what? No, I want to real the post only one approach, right? Okay. So yeah, this is column number. Yeah, must reminder and division. Okay. Fuck it. Finally and easy. Acceptance rate. So acceptance rate was actually even lower. This should be a medium. Yes, it should. Actually, it should. Yes, it should. Yes, actually it is. So now let's solve one more DP problem. Let me pick up some medium one because we just solved, or we can solve easy one very quickly as well, and one medium, because this stream was supposed to be a dynamic programming question. How much time do I have? Yes. So mean cost climbing stairs. You are given integer cost where cost I is cost of I step on staircase. Once you pay the cost, you can either climb 1 or 2 steps. Okay. You can either step with 0 or step with index 1. The minimum cost to reach the top of the floor. So okay, again, we're gonna have a sub problem straight away. So the sub problem in our case is gonna be some function, I don't know, compute the minimum thing for the specific step that we are in, so index, and it's gonna return the minimum possible one. And now if index bigger or equal to length of cost. Sorry, I lost some messages. Welcome. How's this tag? Easy. Yeah. Come to my. The solution starting. Yeah, this solution is completely about dividing and module operation. Okay, cheap viewers. Okay, this should be blocked. I don't have any moderators. Welcome. Next problem statement I will try to solve with you. I am right now. Good. Let's go solve it. Directly use reminder. Yes. Using reminder. Yes. Crazy man. Good work. Thank you. So now here, if we equal to the length of cost or more, it means the steps are done. So we did all the steps. We should return 0 because price of it when we already done it is 0. Then we should return minimum, right? So we just observe result. Every single time we can climb, every single time we can climb 1 or 2 steps, which means we have this branching. So from current index, what we can get is minimum compute index plus 1 or compute index plus 2. Yes, and it should be plus 1, right? Because we did no, plus cost index, because this is the cost we paid for current step, right? And then whatever is left on the further steps, and then we return a result, and then we return compute mean compute from index 0 or compute from index 1. So output 15 because we start our index 1, so we also start index 1, we pay for it, and next thing we're gonna have 0 gonna be the minimum. Yes, it works, but it's brute force again. It's exponential time in this case, because every single time we're spawning 2 function calls. Again, same thing, we can put cache or we can try it from the end straight away. So our DP is going to be 0 times length cost plus 1. So we're going to do bottom up straight away. And then we are starting from DP. We can even pre-allocate some further thing, because I think it's going to be 2. If we're on the last element here, let's say we can do 2 steps. So this is index 2, and 2 plus 2 going to be 4. So it's going to be 2 plus 2 equals 4. So in plus 3 in this case. And we are defining all of them as 0, and we start from for index in range 0 to length cost plus 1, just length cost, and reversed. Exactly. And then what we are doing, DP for current index is going to be exactly the same thing. So instead of, we can straight away copy it, and instead of compute, we're just gonna call DP index plus 1, and here DP index plus 2. Yes, plus cost. And in the end, we just return DP 0. Because this, we should return this one. DP 0, DP 1 as a mean. DP 1, something like that, I guess should work. No? 35. Okay, once again. 0 plus cost index. Okay, this is strange why it doesn't work. It should actually work. Because plus 1, come on. Yeah, great job. Now it's linear because it's only for loop, and space can be optimized as we spoke before using the just variables. And now one more medium DP question. So house robber. A professional robber planning to rob houses along the street. Each house has a certain amount of money stashed. The only constraint stopping you from robbing each of them is that adjacent houses have security systems connected to, and it will automatically contact the police if 2 adjacent houses were broken into the same night. Given an integer array nums representing the amount of money of each house, return the maximum amount of money you can rob tonight without alerting the police. So the key things here to understand is that once we robbed, let's say 2, we cannot rob 3 and 1 because they are adjacent. So we can either rob 2 or proceed and then rob 3, and in this case we cannot rob 2 and 1, and so on. So basically every single index we again doing exactly the same. So compute for every single house that we are right now. If index equals length nums, then we are doing, or sorry, and return 0. And now for every particular index, what we can do? We can rob it. We should return what should we return? Fuck. Maximum amount of money. So we are trying to get the maximum, and our maximum can be so actually result is gonna be maximum for robbing current house plus robbing the one after the next. So compute index plus 2, because the next one we cannot rob already, and previous ones we just robbed. And now yeah. Or another choice would be to just rob the next one, index plus 1, and that will be it. Then we return result, and now we're returning what should be our maximum if we start with house 0. Actually this one is for me easier than previous one, the easy one. It's again exponential, and here it's very easy to kind of calculate because we are doing exactly 2 function calls every single current function call. So every single compute call would spawn 2 more recursive compute calls. And to optimize, we can add cache for specific index, or we can again try to do bottom up. So our dynamic programming array or cache is going to be, let's name it cache this time, I don't know, cache is equal 0 times length nums plus 2, again plus 2 because in the last index we can jump 2 plus. So we should have this index, and let's say we have length equals to 4. So last index is going to be 3, 3 plus 2 equals 5, so 5 should be a valid index, so we should allocate 4 plus 2 equals 6, yes, exactly. And now we are trying from the, since it's bottom up, we are kind of starting with the last index that we might possibly have, except the base case. So we are starting here from the I in reversed range from 0 to length nums, right? And we're starting, doing exactly the same. So now we can just copy this guy. So dp for index I is going to be maximum nums of index I plus compute, and instead of compute here we are putting dp, as I told you, and here we put in dp. And then we just return it, return dp I 0, sorry, dp 0. As simple as that. Should actually work. Let's check it. dp is not defined, yeah, because it's cache. Shit, it's gonna be I. My god, yeah. I'm in a hurry already because I should go. Yeah. I just know it should work because it's generally easy DP problem. Now it's again linear because we have only one for and all one for space, which can be improved using the variables. So I think that will be it for today, guys. So today, recap, we solved 3 dynamic programming questions plus 1 dynamic programming question for Microsoft and plus 1 problem pasted in the chat, which I didn't know before, so it was quite hard to be honest with this acceptance rate, which is kind of shouldn't be easy to be honest, but we anyway solved it. So thank you so much for being with me, guys. Next time we're gonna continue. Today we didn't have any system design, but next time we will maybe fix it. So thank you all again. It was me, Andriy, software engineer from Microsoft. Don't forget to subscribe on my Telegram, which is important because I'm doing stream scheduling there and all insights, stuff like that. So don't forget. It was me,